Welcome to basic convergence and divergence theory. So first up, we have a theorem, which is called the nth term test for divergence. And essentially what the nth term test for divergence says is if the limit as n goes to infinity of a sub n does not equal 0, then the infinite series, the sum from n equals 1 to infinity of a sub n, diverges. So if we want our sum to converge, we have to be adding on essentially negligible pieces to our sum at the end. So this values have to go to 0. And so just because the limit goes to 0 does not guarantee that the sum converges. But if the limit does not go to 0, we at least know that the sum of the an has to diverge. So for example, let's show that the sum from n equals 1 to infinity of n minus 1 over n diverges. So note the limit as n goes to infinity of a sub n is simply the limit as n goes to infinity of n minus 1 over n. And of course, that is just equal to 1. So, which is non-zero. So by the nth test for nth term test, we have the series diverges. Next up, we have another theorem, which simply states that if we happen to add on additional terms or subtract off additional terms, so if we add on or subtract off a finite number of terms, to a series, it does not change whether the series converges or diverges. So a very useful version of this is that the sum from n equals k to infinity of a sub n converges if and only if the sum from n equals 1 to infinity of a sub n converges. Convergence really only matters what's happening at the end of your sum, right? Because you could have 1,000,000 as the first part of your sum, but as long as the end of it goes to becomes negligible, you'll have convergence. Similarly, the first part of your sum could be basically equal to 0, but if the end of your series, if the terms get larger, you will still go to infinity. So it doesn't really matter what's happening at the beginning of the series, it only matters what's happening at the end. So for example, if we want to show that the series from n equals 100 to infinity of 1 over, the sum from n equals 100 to infinity of 1 over n diverges, this is just the sum from n equals 1 to infinity of 1 over n minus the sum from n equals 1 to 99, right? We're eliminating those first 99 terms of 1 over n. The sum from 1 over infinity sum from n equals 1 to infinity of 1 over n is essentially infinity. And then the second part, the sum from n equals 1 to infinity of 1 over n is just a finite number. So when we do that subtraction, we wind up still getting infinity. So this diverges. This is sort of showing why the rule I wrote up here works. So this same trick applies whether the series we're comparing to converges or diverges. So that is it for section 8.2. In section 8.3, we will get more into various different techniques we have for testing for convergence and divergence.